so I will take over for the using computer stuff. To have to get a compiler guy. Yeah, who has not installed Docker so far on his machine? Okay. Can you help her installing Docker? Oh, you installed. Okay. Who has not downloaded the image so far? Who still needs to do that? Perfect. So I can get started right away. So basically, we've put together a container, a Docker container, just to abstract away the underlying system. So we have a uniform system for all of you. I'm quickly going through this command. So we have the Docker command. We are going to run a container. So we have images. That's what we put together. And if you execute an image, one instance of an image is called a container. So this flag -it just means you want to interactively use this container. So you get a terminal inside the container that you can use. And we're going to throw away the container after we've executed the tutorial, just so we do not spam your hard drive. This part is optionally. What we're doing here is we are mounting a local folder, in this case the tutorial folder in my home drive, as in the /shared folder in the Docker container. We're doing this. That's not really required for TaPaSCo, but we're going to put together a image flow today, and if you're using this mapped directory, you can look at the images falling out of your image processing flow in the end. So you should do that if you want to look at the images, but you do not have to do that, and it's not required for TaPaSCo. And that's basically the name of the image we put together. That's my name because it's registered under my Docker Hub account, and that's the name of the tutorial, the image we put together, and this is the tag, so we tagged it for this conference basically. So if you run that command, you will end up in a root shell inside the Docker. Okay, so please try to do that on your machines and let us know if anything goes wrong with that command. So then let's move on. If you go to the folder /root/TaPaSCo, you will find a TaPaSCo instance inside the Docker container. So this is basically what we have on GitHub right now on the branch 2018.2, which is obviously a release in the year 2018. We never did. So yeah. But if you go there, that's basically the same thing that you would get if you would git pull TaPaSCo from GitHub right now. We haven't modified it only a little bit for this tutorial, but that's not really relevant. So let's look what we have here. We have a lot of directories. Let's go through it in just an alphabetic order here. So the first thing is the Arch directory, which contains the Tcl scripts mainly for the basic architectures. So we have this Axi4 based architecture right now, which you would find inside this folder. The bin folder is for the Scala part. That's just the output directory for the classes. In CMake, we have the basic CMake definitions for TaPaSCo, so you can use TaPaSCo libraries from your project with CMake. In common, there's another part of the architecture. In documentation, there is supposed to be some documentation. I'm not sure about that. Yeah, there's a bit of it. So the rest is this tutorials, the documentation, so to say. In examples, you have some usage examples. They will get relevant for you later on in the tutorial. Same as the JSON examples here. Under kernel, we have a list of very basic kernels that we provide together with TaPaSCo as HLS kernels. That's really super simple stuff, like the sum of computing the sum of two arrays, or the elements in one array, or initializing an array, or this rotating by 13 chiffre, called sometimes Caesar chiffre. So that's very simple kernels, just to experiment when you get your TaPaSCo delivered. In platform, there's the platform specific parts of TaPaSCo, so the tickle scripts to set up the different platforms that we support. Another interesting, so you always have to remember TaPaSCo is basically made of two things. That's on the one hand, that's the software that realizes the flow, so you can run HLS from TaPaSCo, you can do all this composing of bit streams with TaPaSCo. That is all realized in the Scala programming language, and all the classes relevant for that you will find under the source folder, and the C and C++ stuff is distributed across the architecture, platform, and this last folder is the TLKM, which basically means TaPaSCo loadable kernel module. So that's the kernel driver we provide, so you can use TaPaSCo on your machine. So that's a basic Linux driver that works on the different machines and different platforms. Okay, any questions so far? Okay, perfect. The first thing you always need if you want to use TaPaSCo, and as I just said, it's Scala based, the software flow. You will need some form of Scala, and for that you need Java and the Scala build tool SBT. So we generally recommend to use the so-called SDK-man tool to install these tools, because it's giving you a way to install multiple instances or different JDKs and SDKs at the same time. You could also use the SBT and Java provided by your package manager, for example, but we will just use this SDK-man today. So the installation of SDK-man itself is pretty simple. You'll just go to this web page for SDK-man and copy the command which is written down here. It's just a simple curl command, downloading a bash script from the website and executing that in your terminal. So I'll just do that, and you should follow me so you can install your Java and SBT in a minute. So it has a lot of nice graphics and all that, and that's it. We're done with installing SDK-man. So if you have any problems following that step, just let me know. Sorry, the command, I'll get that back for you. So we'll go on. So then the first thing we need to install to use TaPaSCo is a Java or a JDK. So we'll just use the SDK-man tool, which is called SDK, and install Java with that. That's all you need to do to install Java. Hit enter, and oh, I forgot to source that one. So you first have to source the setup script of SDK-man once, and then you can run SDK install Java, and we'll start to download Java for you. Okay, in the meantime, our SDK install Java has finished. The other thing we need is the SBT tool, which is the Scala build tool. So that's something like CMake for Scala, if you want to call it that way. So just a similar command to what we just did. We just do an SDK install SBT now. That should be a bit faster than the Java one, because the tool is smaller and faster to install. Okay, let's continue. So we have everything now that we need to build TaPaSCo. So the first thing we're going to do, we're going to source the setup sh of TaPaSCo, which is just setting up some paths for you and setting the TaPaSCo home folder to basically path setup. So you see, if you run that command, that TaPaSCo home is in the folder we have installed our TaPaSCo to. Okay, everybody got that? Okay. So next thing is we need to do is to build the Scala part of TaPaSCo. So we're using the Scala build tool, which is called SBT, and we're going to assemble or build TaPaSCo with the following command. and then just hit enter, and you'll see that the build will start. And yeah, this is going to take a second, so okay, somebody's still waiting for the compilation. Huh. Perfect. Faster than I thought. Quick, slower than you thought. So perfect. The next thing we need to build is the C and C++ part of TaPaSCo, which is basically the software stack you're going to use to interface with your accelerator. That's pretty easy because we have a script for that, so you don't need to get into CMake or make or config or autoconfigure. I don't know what else there's out there. Ninja, GN. So you basically only need to call this TaPaSCo build libs command and run that one on your machine. Okay. Then we can still look at what we've just built for the C part. If you have a look in your TaPaSCo directory build install lib, you will see the free libraries. These are the platform library, the lib TaPaSCo common, which is common parts of TaPaSCo library, and lib TaPaSCo itself, which is the library you are going to interact with at the end of the day if you want to interface with your accelerator.